Math 102. This is notes 9, page 6 and 7. I hope I get them both in. We're going to start looking at fractional exponents. We've looked at positive exponents, negative exponents, and now we can work with fractional exponents. In fact, an exponent can be any real number. So you can even use pi, which is irrational, as an exponent. The exponential rules are not going to change. It doesn't matter what type of exponent you have. If you have a to the m times a to the m, remember, describe what you're seeing here. You're multiplying the same base. You add the exponents. This is the same as using the same base, add the exponents. So just like x to the fourth times x to the second is x to the sixth, if we had something like x to the 1/2 times x to the 1/2, well, that'd be x to the 1/2 plus 1/2, just x to the first, which is just x. So the exponential rules will not change. And so that's not going to be a big deal. What we really want to get at right now is, what does it mean to raise x to the 1/2 power? What? Well, let's think about it. We know that x to the 1/2 times x to the 1/2 is just x. We also know that the square root of x times the square root of x, the square root of x is that number when you multiply it times itself, gives you back x. Now, we can also notice that if you take x to the 1/2 and square it, that's power to a power, so you multiply the exponents. That's x to the 1/2 times 2. Oh, it's kind of small there. Well, 1/2 times 2, that's just x. We also know that the square root of x squared again is x, as long as x is a positive number. So notice the similarities here. And remember the definition. The square root of x is that number when squared will give you x. Or the square root of x is that number when you multiply it times itself will give you x. Well, notice that for x to the 1/2, if we square x to the 1/2, we get x. If we multiply x to the 1/2 times itself, we get x. So it must be that the x to the 1/2 is the same as the square root of x. Okay? Now, check this out. There's a connection here. Remember, the square root has an invisible index of 2, and the exponent also has, the x has an exponent of 1. And remember, the index divides into the exponent when you're working with radicals, and there it is, the index divides into the exponent. So it's really the consistent pattern that we've seen, okay? So let's look at another example before we sort of tie it together. So remember, a to the n raised to the m again, power to a power, you multiply the exponents, and this is for any exponent. So x to the 1/3 raised to the 3rd power, that's power to a power, you would multiply the exponents. Oops, 1/3 times 3. Sorry, that's so small, hard to see, but that's 3 times 1/3. Well, that's x to the 1st, or just x. Well, we also know the cube root of x cubed gives you x. And by definition, the cube root of x is that number, when cubed, that will give you x. But we see that if we cube x to the 1/3, we also get x. So x to the 1/3 must be the same as the cube root of x. So again, notice the index and the exponent. The exponent on the x is 1. And when we were simplifying with radicals before, we knew the index divided into the exponent, so we can see that if I did that, take the exponent, divide it by the index, there it is, x to the 1/3. Okay, so now let's look at page 7. So here's the pattern. X to the 1 over n means the nth root of x. So a fractional exponent is a radical in disguise. And the denominator of your fraction in your exponent is your index for your radical. Okay, so 8 raised to the 1/3. What is that? Well, this is really a radical, and it would be a cube root because the denominator of the fractional exponent is 3, so that would be the index, and then the cube root of 8 is 2. So 8 to the 1/3 power is 2. 16 to the 1/4 power. So if it's a fractional exponent, it's a radical in disguise. Well, what's the root? Because if it's a radical, it must be a root. Well, look at that denominator. The denominator tells you the root. So the type of radical this is a 4th root of 16, and the 4th root of 16 is 2. But watch out, some order of operation reminders. This negative is not in parentheses, so this is the opposite of 16 to the 1/4. So it's the opposite of, then take the radical, 4th root of 16. That's negative 2. But with this negative inside the parentheses, that would be the 4th root of negative 16, and that's not a real number. It's not exactly I. It's really like the square root of I, because I is the square root of negative 1. So for 4th roots of negative numbers, we'll just go ahead and say it's not a real number. But if it was a square root of negative 16, we could call that 4i. So now, so far we've only looked at exponents where the numerator for the fraction was 1. What about something like 8 to the 2/3? How could we figure out what that means? Well, what you want to realize is that 8 to the 2/3 you can also write as 8 to the 2 times 1/3, because 2 times 1/3 is indeed 2/3. Now, if you're multiplying exponents, that must have come from power to a power. So we're just using the exponential rule backwards. So that would be like 8 squared, then raised to the 1/3 power. Well, 1/3 power is the cube root. So that would be the cube root of 8 squared. And then we can do this arithmetic. 8 squared is 64, and the cube root of 64 is 4. Okay? Notice what happened here. The fractional exponent, the numerator was the power. I squared something. The denominator, I just don't have enough space here. That was the root. I took the cube root. And here I squared first and then took the cube root. I'm going to show you it doesn't matter which of these 2 steps you do first, because multiplication is commutative. We can also write 2/3 as 1/3 times 2. So if you're multiplying the exponents, you must have done power to a power. So this is 8 to the 1/3 squared. The 1/3 power is a cube root. So take the cube root of 8, then square it. Now let's do the arithmetic. The cube root of 8 is 2. Now square that answer. 2 squared is 4. So what you want to notice here is a fractional exponent is essentially a 2-stepper. The numerator tells you the power, the denominator tells you the root. So we'll put this over in the fact box over here. X raised to the m over n is the nth root of x. You can do the radical first, raised to the nth power, or you can do the power first and then take the nth root. It doesn't matter what you just need to which you do first. What does matter is the numerator of the exponent tells you which power to raise the base to, and the denominator tells you which root to take. And you can do it in any order, technically. Practically, taking the root is often easier first because it cuts your number down to a smaller size, just easier to deal with. Okay, so let's think about this. Just practice with it. Negative 32 raised to the 3/5 power. So the 3 tells me to cube it. That's the power. The 5 tells me to take the 5th root. It's a two-step process. You can do either step in either order. I don't know off the top of my head what 32 cubed is. So I'm going to take the 5th root first. I'm going to say the 5th root of negative 32 first and then cube that answer. The 5th root of negative 32 is negative 2. Cube that answer. That's negative 8. So doing the root can just be easier sometimes. All right. 4 raised to the negative 5/2. I threw a negative in there. You know what I did? I added another step. This is a triple step thing. The negative says take the reciprocal of the base. The numerator says 5th power. The denominator says square root. So you got 3 things to do with that base of 4. Technically, it doesn't matter which you do first. I prefer to flip first, so I don't forget. So that's 1 over 4 to the 5/2. And then again, 4 to the 5th. Actually, I think that's 625, but I still think the square root's easier. It may not be 625. No, I was thinking 5 to the 4th. That ain't it. So there it is, 4 to the 5th. I don't know what that is. So I'm going to take the square root of 4 first and then raise to the 5th power. Square root of 4 is 2. And now the last thing I'm going to do is the 5th power to the 5th is 32. So this is 1 over 32. So none of the steps are hard, but it's 3 steps. Okay. Now, watch out for tricky ones like this. Okay. Negative 16 to the 3/4. We're going to start talking about radical form. When I write a radical for the 4th root here, that's going to be called radical form. And that's what I've been doing, is putting this in radical form. So this would be the 4th root of negative 16 and then cubed. And if you have a 4th root of a negative number, we're just going to stop right there and say not a real number. Okay, so watch out. Even roots of negative numbers are not real numbers. The square root, oh goodness, the square root of negative 16, we can call that 4i now. So that I would have you do. But the 4th root of negative 16 we really haven't defined. Odd roots of negative numbers are perfectly real numbers. Okay. So one final note on just calculating numerical bases to fractional exponents. What we have to do is change from exponential form, which is what this is called, to radical form, which is what this is called. Once you do that, it's pretty easy to calculate the value. However, when you're simplifying radical expressions that have variables with fractional exponents, not bases with fractional exponents, but variables with fractional exponents, like x to the 3/2, you almost always want to leave the problem in exponential form. and just apply the appropriate exponential rule. For instance, if I ask you to simplify x to the fourth times x to the 1/3, you should notice it's all one term. And you have the same base showing up within that same term, so you can simplify. And you just use the exponential rule that applies. You're multiplying the same base, so you add the exponents. So it would be x to the 1/4 plus 1/3. Now that's a lovely arithmetic problem. You need an LCD for that exponent. It's 12. That's x to the, multiply this top and bottom by 3, that's 3/12. Multiply this top and bottom by 4, 4/12. That's x to the 7/12. Okay? And we'll leave it that way. The rule of thumb is going to be, hey, I started with fractional exponents in my problem. I'm going to leave fractional exponents in my answer. I could, at some point, ask you to change this to radical form. So that's when you'd realize, oh, the denominator of that exponent, that's a root. So this is a 12th root of x to the 7th. And notice when we have variables, you're going to see that we actually put the exponent first and then the radical on the outside. That's just typical format. So we'll work with these fractional exponents more in the next set of notes.